Assalamualaikum and a very good day everyone. My name is Shahlinney Lipeh and I'm a researcher from the Forest Research Institute of Malaysia. Today I will be presenting part of my PhD dissertation thesis regarding the application of infrared spectroscopy for determination of wood natural durability. So in 2009, the National Timber Industry Policy was introduced to aim the target of achieving a higher revenue for determination timber industry. 7 trusts were introduced, but for my study today, we will only be concentrating on the trust number 2 and trust number 3, which is regarding the supply of raw materials and the using of innovation and technology. So what is wood? Wood is considered as a versatile material with a high strength to weight ratio, easy to work with, and they look nice. However, despite all these advantages, they are highly susceptible to degradation, such as to weather, the rain, and the UV light, as well as becoming the food source for many organisms, such as the decay fungi and termites. However, some of the timber can be highly durable and can withstand all this degradation. So some of the factors that contribute to this durability is the extractive content that is available inside the timber that help protect them from decay and the termites. Furthermore, there's also some durability issues that contribute to durability of the timbers. So the raw materials that we have now are sourced from from the plantation species and secondary forests, where the timber from these sources are considered as less durable due to the lack of extractive content. There's also the issues of the durability inside the wood itself, where even from the same species and the same tree, they have different durability. For example, the lower part of the trees are more durable compared to the upper part, as they have more extractive concentration at the lower part. In addition, the timber market also using only one common local trait. For example, Kuring is the local trait name for all the 30 species of Deuterocarpus. This poses a problem as some of the species in this green group have a durability range from class 1 durable to class 4 non-durable. Durability can be assessed through 2 standardized methods. The first one is through field test, where all the samples are cut to smaller blocks and exposed in outdoors to all the organisms. The second one is through a more accelerated laboratory test, where a smaller pieces of the wood samples are exposed directly to a specific fungus or insect species. Based on the result of this test, we can assess the visual rating as well as the wet loss, and the classification will be given from class 1 to class 5, from very durable to perishable. However, for the tropical countries like Malaysia, we only have 4 classifications, and the life of which is shorter compared to the temperate due to our extreme weather and the existence of various organisms that can degrade the timber. This method are highly time consuming, where it can take from months to years before we can access the durability, laborers, and only using a small sample size, which might not represent all the durability of these samples of the species. And there are also various standardized methods based on the region, such as the American standard, the European standard, as well as the Australian and the Japanese standard. Therefore, there's a need for a rapid and non-destructive method for assessing wood durability. So the aim of our study is to produce a rapid and non-destructive technique for sorting a large number of wood samples using the infrared spectroscopy combined with a chemometric analysis. However, our ultimate objective at the end of the study is, of course, to produce a real-time sorting of wood into certain durability classes, and where this can give a proper application according to durability classification, which might enhance the service life of the timber. And finally, we hope that this can also improve the consumer confidence in using timber as a raw material. So, infrared spectroscopy is a study of matters and light. Infrared spectroscopy is a light that has a longer wavelength than the visible light. So when this light passes through a material, some of this light will be observed and some will be transmitted. So this will produce a spectrum that has a unit region called the fingerprint region that can be used to identify an unknown chemicals or to verify whether certain chemicals are present inside the samples. So this method has been used to characterize many of the wood chemical compounds, such as wood extractive, that contribute to wood natural durability. For our method, the wood species that we use are the Alaskan yellow cedar and the western juniper that we obtain from the wood disc and also from the processed wood timber. So this sample were then converted to a smaller pieces where we will access the decay and termite resistance using a standardized method in the lab. This is followed by the chemical extractive where we analyze the amount of extractive inside each of this timber. Finally, the sample will run under the FTIR and to identify the important extractive that contribute to the durability in the species, and then we did the chemometric analysis. So for the result of our study, based on this table, the y-axis represents the amount of extractive that we found inside the wood based on the 3 different solvents, while the x-axis represents the wet loss after exposure to the 2 species of decay fungi and 2 termites. So based on this result, we found out that the methanol, which take out the phenolic substance and terpenoids, which is part of some of the important extractive that contribute to wood durability, has a higher correlation with the wet loss or the durability of the timbers to decay fungi and termites, while the other extraction only have a small relationship. So this showed there's a relationship between the samples that we tested with the durability and the extractive content. Next, we run the near-infrared spectroscopy for the extractive. So for this study, we used the extractive-free wood timbers that we produced earlier, and we treated each of the samples with caracal, which is a non-extractive that contribute to the durability of Alaskan yellow cedar. So when we run it under the infrared spectroscopy, we discovered that it can differentiate between different concentration of caracal, even from as low as 3%. So there are several peaks that shows significant differences that contribute to the functional group of this extractive. Then we try to detect whether the extractive can also be present inside the wood. So we did the chemometric analysis and produced the principal component analysis. So based on this table, the percentage of caracal solution that we applied inside the wood are much smaller when we put it inside the timbers. So when we run the principal component analysis on these samples, we discovered that it can differentiate between the lower concentration, like the 3 and 5% of caracal, in the principal component analysis. And based on the result, almost 97% of the variability in our test contribute by the existence of this caracal inside the samples. However, some of the concentration are overlapped and makes it a bit difficult for us to differentiate between the concentration. For the third result, we use the infrared spectroscopy and study the fingerprint region against the durability to decay fungi, which is the Glypharium tribium. So using the infrared spectroscopy, we were able to identify the highly resistant, as well as the moderately resistant and non-resistant samples. And when we run the principal component analysis, we were able to achieve almost 70% of our data can be differentiated based on this durability classification. This is much lower than the one that we obtained earlier in the Cabercol test. However, it shows a promising result where we can still differentiate between the highly resistant and resistant samples. To conclude our study, this study showed that infrared spectroscopy can be used to detect extractives that contribute to wood nurturability, but only to those more than 5%. And there's also a potential for the infrared spectroscopy to be used to sort durability in a rapid and non-destructive way. However, there's also certain limitation in our study, such as the pre-processing of the spectral data, as well as the complexity of running the combiometric analysis. The infrared spectroscopy are also highly sensitive to moisture inside the wood, as well as the particle size. So back to our ultimate objective, we were able to produce a method that has a real-time sorting of a large number of samples into its durability classes. And hopefully this can give a better advice on the proper application according to durability classification. For example, the highly durable and moderately durable can be used for outdoor application, or the non-durable can still be used for the indoor or outdoor application, but with a proper preservative treatment to protect them. Hopefully, this can also improve the consumer confidence in utilizing timbers based on the durability classification. So in the future, we plan to concentrate on wood with higher extractive content, such as the one that we found in the tropical, as the timbers that we use in the study are mainly coming from the temperate country. So our tropical species, including the one that we found in Malaysia, the extractive content are much higher, from 5 to 15%. So this will be better for our infrared spectroscopy study. We also need a more extensive data on the field and laboratory tests, especially on the species that's coming from the secondary forest and plantation species, as well as the less utilized species, which the data are still lacking. There's also a possibility of using portable spectrometers for field application, which I will explain later. This can also be used for our Malaysian industry and can also be used for our industry policymakers as a continuation to our national timber industry policy on how to increase our revenue in timbers and wood products industry. So with the advancements of technology, a portable spectrometers is already available in the market. So there's a possibility of using such portable spectrometers to assess the durability straight from the forest or from the tree nursery without having to bring all these samples back to the lab. There's also the possibility of integrating infrared spectroscopy in a large-scale production, such as in the sawmill, for direct assessment of the wood durability. So instead of differentiating it based on the just the species, we can also differentiate the timbers based on their durability classification. With that, I thank you for your attention and welcome any question from the floor.